Okay, so you multiply the A times the C together and get negative 12. You write down the factors of negative 12 and find a pair that add up to equal the B equals 1. You rewrite the equation. Then you factored out the common term, the GCF, and came up with the answer. Now, I need you to compare that answer to step number 3. What do you see about this answer compared to these numbers that I circled in step number 3? Here's step number 3. Here's the answer. Do you see something that's related there? You see this number is a negative 3 and a positive 4? You see this number is negative 3 and a positive 4. There's a shortcut. This shortcut only occurs if the A is equal to 1. If and only if the A is equal to 1, there is a shortcut. Can you use the shortcut on all the problems? Only when? If A is equal to 1, you can skip this step, you can skip these steps, and go directly to the answer. Now, if we had more time, I would have you do a bunch more examples and see that it really does work every single time. When you go through all of these steps, you get to the same place if what? If A is equal to 1. After you factor out the GCF. The first step is still the first step. What is the first step? You still have to factor out the GCF. After you factor out the GCF, if the A is equal to 1, then you can use a shortcut. Well, let's see what the shortcut is on example number 2. Okay, on example number 2, what is the A? Can I use the shortcut on this problem? You can use the shortcut if A is equal to 1. There's no GCF. I still have to multiply the first term times the last term. And so I still have to multiply the A times the C, and in that problem that's going to be a 10. I still have to write down the factors of 10. I still have to find the factors of 10 that add up to equal the B. Only this B is negative 7. And I don't have any negative numbers. But that's why I wrote this rule over here on the board to remind you that a negative times a negative makes a positive. If this is negative, they multiply together to get the positive 10. If this is negative, they multiply together to get the positive 10. Now that I have some negative signs in there, do I have a pair that are going to add up to equal to the negative 7? You can, if you want to, go through all the steps. If you go through all the steps, down here when you're done, that's what you're going to have. If and only if the A is 1, after you factor out the GCF, you can skip these steps right here and go directly to the answer. Does that seem a little easier? Now, I had one girl ask me can I go ahead and do the steps? Sure, you'll get to the same answer. This is just a shortcut that you can only use if A is equal to 1. Do you hear me emphasizing that over and over again? Because guess what mistake people make? They try to use the shortcut when it doesn't apply. Can I use the shortcut here? What's the A? What's the B? And the C? And this one does not have a GCF. If you multiply the first term times the second term, you get negative 25. The factors of 25 are negative 1 times 25 and negative 5 times 5. Do any of those add up to get 0? Which pair would add up to get 0? If you want to, you can do all of these steps, or since the A is equal to 1, you can go directly to the answer. So possibly this might help you kind of speed up some of your work. Now, this particular pattern not only has that shortcut, this also has another pattern. This is also called the difference of two squares. Because 1 is a perfect square number. A perfect square number is a number that when you take the square root, the answer is a whole number. What's the square root of 1? 1. What's the square root of 25? 5. It's also a perfect square number. So this right here is a difference because it subtracts, and this is a perfect square number, and this is a perfect square number. And so the perfect square number will always have this plus minus pattern if it is the difference of two squares. Now, can I use my shortcut on this problem? Well, before we can answer for sure, we have to factor out the GCF. So, what is the GCF? Okay, I need to factor out a GCF. When you factor out a GCF, you do not throw the GCF out the window. It's going to be down here in my answer. Okay, so what is the A? What's the B? And the C is negative 9. If this is a 0, if this is a negative, if the 9 and the 4 are perfect square numbers, there's one more shortcut. I don't have to go through all of these steps. I can go right here to the answer. The answer is going to have that plus minus or minus plus pattern. What was the A? What's the square root of 4? And it had an x, so that's going to be 2x and 2x. What was the C? It was actually negative 9, but I've already taken care of the negative by putting that sign right there, negative. What is the square root of 9? But there's one thing I'm missing. What am I missing? What was the GCF? It does not get thrown away. The GCF is out here in front of the problem. And so these are a couple of shortcuts that can make your life hopefully a little easier as you're trying to factor these trinomials.